Very few of the pioneers in the search for the atom were actually looking for ultimate smallness. Nevertheless, 25 centuries of curiosity about the basic nature of matter gradually produced a mosaic of scholarly ideas and observations, which led to the work of this man, the English chemist John Dalton. Dalton fell backwards through the door, which led to his chemical atomic theory. He was actually looking for an answer to why water absorbs more of one kind of gas and less of another. He decided that when water absorbs a gas, particles of the gas must fit into spaces or pores between particles of the water. Why does water absorb more of one kind of gas and less of another? Dalton thought some kinds of gas particles were lighter, so relatively few would squeeze between the water particles. While with another kind of gas, heavier particles would sink in greater numbers between the pores in the water. Dalton's theories implied that matter was made up of individual particles with spaces between them. Dalton concluded that elements of matter consist of characteristic kinds of particles. The particles or atoms of an element are identical to each other. Atoms are indivisible. There are as many kinds of atoms as there are elements. The atoms of one element cannot be converted into the atoms of another element. Atoms in chemical reactions are neither created nor destroyed, merely rearranged. Dalton's ideas suggested a way of explaining an earlier observation, Prost's law of definite proportions. If each element is a particular kind of atom, then these atoms combine in fixed numbers to form what Dalton called compound atoms. Dalton extended this thinking into his law of multiple proportions, which described how different compound atoms can be formed by two basic elements. The simplest possible formula is one atom of each kind. Next simplest is one of one kind and two of another. After Dalton, the pace of discovery quickened.